Perfect. Thanks.
Okay.
Alrighty. Well, hey everyone. So I am actually a kind of machine learning theorist, so slightly out of my depth in this discussion, but what I hope to do in the next 10 minutes is try and put forward something that is actually getting quite a lot of attention in the theory of ML literature, that is getting not that much attention in anything more empirical and anything more kind of on the deployment side of ML, and hopefully in the next 10 minutes I'll convince you that is a problem. So my name is Devon. I'm a lecturer at Wits University. I run the Cognition, Adaptation, and Learning Lab. That's our little mouse logo at the bottom left. We're mainly a computational linguistics and neuroscience lab, and we can maybe chat more about that kind of afterwards if anyone's interested. But to jump off the talk, the kind of main result that leads to a lot of what I wanted to speak about is
No, you can go ahead.
Is neural scaling laws. This is at this point quite a famous result. Coming out of OpenAI in 2020, and it is really the big foundation of why we think that LLMs can be deployed into mainstream systems and are going to continue to work over time. So what this graph shows is that as you increase dataset size from left to right, you see that the performance of the model improves. In other words, the test loss goes down, and that's important that it's test loss, because that's the kind of metric that actually tells you how well it's going to do in practice. And then the two graphs at the bottom, they're a little bit messier, but the same story holds behind the chairs. As I increase the dataset size along the x-axis, the test loss should drop consistently. And that is kind of motivating this big kind of foundation model line of work that we're seeing kind of coming out of all these companies at the moment. And even in academia now, a lot of work is based around foundation models. The flip side to this is something which is called model collapse. And that's what I want to kind of put forward to this community today, is something that we should all be really aware of. And that actually is something that I think every single person in this room can have a role in fixing. So what we're seeing currently happening in the deployment of ML is the fact that we have some version of a model, right? So we have some data and model 0. Now that's the first instantiation of GPT that was released to the public, maybe GPT-2, okay? And then that model is really good at generating new language, so everyone uses it. And then that is used to create a new version of the same data set, call it dataset 1. Now, the important thing to remember is that the original data, 0, is still present in dataset 1, but it's no longer all of it. There is now some generated content, or in other words, some synthetic data in the dataset that is used to train a subsequent model. And we see this happening over time, where you have generations of models being trained, then a new amount of synthetic data being produced. That synthetic data enters the training set for a subsequent model. Now, the problem with this is that if you look at the neural scaling laws, while you take into account the inclusion of synthetic data, number one, the neural scaling laws completely start to fail, all right? If you have roughly 50% of your data being synthetic, which is a bit unrealistic at the moment, but we are getting there in terms of the amount of synthetic content on the internet, neural scaling laws will essentially plateau from the start. If even 10% of the data set is synthetic, it will start to plateau over time. And so what this means is that as we're slowly producing more and more content using these models, we're actually inhibiting our ability to make better models in the future. That is still a fairly academic theory perspective of it. Let's look at what this really looks like in practice. So here's a machine learning model, a kind of really powerful generative model that's kind of being used a lot in the literature, working on handwritten digits. So probably the simplest possible data set, right? So that's the original model's generation. So it can create handwritten digits. By generation 5, they're starting to look like smudges. But after generation 20, so having 20 iterations of the cycle of training on digits, producing new digits, training on the produced digits, you end up essentially with these little smudges that look like O's kind of at the center of the screen. And what's happened is that it's identified that that is the closest thing to an average digit it can see in its data set. Now, that still might be a little bit abstract. Again, this is more of a theoretical concept at this point, but it has been done on language models. So this is a result coming out of an OPT 125 million model, so a fairly decent kind of representative transformer model. So if I'm asking it to finish the text at the top there, so the last sentence reads, instead that leading architects designed the parish church towers based on early examples of perpendicular. Generation 0 works great. Revival architecture such as St. John's Cathedral, and then it goes on to talk about architecture. By generation 7, it goes off topic, so it says perpendicular architecture in England. In an interview with the New York Times, Wright said, I don't think there's anything wrong with me being able to do what I want to do. And the language just completely veers off. But now by generation 9, what you end up with is a model that can only speak about jackrabbits. So it says examples of perpendicular architecture, in addition to being home of some of the world's largest population of black-tailed jackrabbits, white-tailed jackrabbits, blue-tailed jackrabbits. And that is model collapse, this inability of models to have expressivity in their use of language as synthetic data enters its training set. This has also been done on vision models, but I am cognizant of my time. But you can see that as the percentage of what's called data poisoning enters our model, so as we have more and more synthetic data, you can get good generation for less and less iterations of this process. If 20% of the data is synthetic, you can essentially only have 1, maybe 2 generations of diffusion models before it becomes highly, highly cursed. Importantly, there is a way to measure this, at least theoretically in the linguistics literature, and that's what's called perplexity. Now, I know this is maybe slightly too in the weeds, but I do have a point for this in a second. But what you need to take away from this is that this blue distribution is the perplexity of the OPT model on English text at the start, right? So when it hasn't seen synthetic data. Every other color is multiple generations of the perplexity of its data set over time. Now, perplexity measures how surprised it is when it reads something. Surprise is good. It means you got information out of the text. What this is essentially showing is that as you do this process of iterative learning, your data distribution will shift all the way to the left, and you end up with data that is actually completely uninformative. Now, again, that's abstract, but what we've done in our lab is consider how this might look like for different distributions of language. And what you will note, and I'll note that the x-axis is on a log scale there, what you will note is that all the languages to the right of English in red are essentially your low resource languages. English and French are the ones that sit to the left. All the others are slightly more low resource on the internet. And as a result, they're the ones that have the perplexity to the right. Now, if you're going to be following this iterative cycle of training, which languages are going to be forgotten first? Which languages is the model going to fail at? It's the ones to the right. I will leave it to this room to try and speculate where African languages are going to sit in this distribution. And so that is my call to action today, and why I kind of want to put this forward to this community is model collapse is an extremely, extremely sophisticated but also dangerous behavior happening in language models at the moment that not enough people who actually engage with low resource languages are speaking about. I would like to put forward that everyone engage in that, not just because it's going to erode our culture and the ability for low resource communities to actually use technologies that are emerging properly, but also the fact that they just scale badly. Genuinely, we are going to have to try and make bigger and bigger models to see relatively less improvement over time. And already this is data showing that training an LLM model uses double the amount of energy or carbon emissions as the average American life. It uses 6 times of any non-American life. And so we already know these models are feeding into very, very unhelpful systems in terms of data, not data, but emissions as well. And that has led to also in the literature what people call the double edge of resource use. So for example, you don't get the benefit of access to technologies. You also feel the effect of climate change first, if you're a marginalized community or low resource community. But on top of that now, with model collapse, these models are just going to scale more poorly for your communities. There is just a lower upper bound in how good ChatGPT is going to be for your language. On top of that, there is also, as we've heard a lot at the moment, the fact that there is exploitation that happens in data curation. There can be exploitation in data curation. There's a whole bunch of issues around that, and we don't fully know how to curate data properly, at least if you're trying to automate it. And so you end up with cases where institutions use data, but they're not the ones, the communities that the data is collected from. All right, you then cannot control the use of your data. It's taken out of its context. We heard that point explicitly this morning. But on top of that now, the data is going to be eroded more quickly for your communities than any other. All right, you will be the ones, if you're a low resource community, you will be the ones to see ChatGPT just completely forget your cultural context first if model collapse continues as it is. And I will note that in the theory literature, data curation is currently the only known solution to model collapse that we found. All right, so anyone in this room who's doing data curation, your role is essentially to try and make sure that this doesn't happen. Okay, this is a quote. I see I have 30 seconds left. Just calling for more engagement from communities to try and bring in different perspectives into this process. Now, there is a slight silver lining, and that is the fact that human language also does this process. So this is an experiment of humans in a lab, and what they have to do is remember a word at the top for a particular scene at the bottom. So this is just a red square moving in a zigzag. They have to do 16 of these scenes. And if you look at the language that people collapse to, it is highly repetitive and not expressive. So you can see that every shape and color moving to the right just maps onto the same word. That is exactly model collapse happening in human language. All right, but humans can re-inject expressivity. And when you ask people or kind of have a mechanism in the lab for humans to become expressive, they end up with a language that is not only expressive, but far more structured. Okay. And here's my second call to action then on a technical side is I think because we are the low resource communities that are engaging with these tools, it is our responsibility to try and figure out how language is evolving in our communities and in our cultures that avoids this model collapse problem. Humans clearly have an innate capacity to solve this. We need to try and figure out what that mechanism is. So here are the key takeaways, and that is that model collapse stands to undermine multiple efforts to address bias in LLMs and machine learning in general. It is currently a theoretical concern that is starting to creep into real-world deployment problems and into real models that are kind of out in the wild. And this is everyone's problem in every aspect of the language modeling pipeline, from curators to the technical people developing our models. And I hope that this community and more communities like it will actually start to take model collapse quite seriously.
Okay, thank you. Are there any questions, comments? Okay, I think yeah, I'll be very interested also in the information security kind of use on the other side in terms of adversaries coming in and actually exploiting these collapses. But yeah, thanks. Devon is here. I'm just trying to check the time. Oh, okay. We do have a little bit of time that came back. I will then play this video that we were supposed to play earlier. This is just from Dr. Mudupe and his reflections on the lab. Unfortunately, so that we can save time in the morning,
everyone.